Hello, everyone. Welcome to my DataCamp tutorial series. I'm Professor Adam Kroom, and today we will focus on Intermediate R Chapter 3. Chapter 3 focuses on functions. Function documentation. Before even thinking of using an R function, you should clarify which arguments it expects. All the relevant details such as a description, usage, and arguments can be found in the documentation. To consult the documentation on the sample function, for example, you can use one of the following R commands. For example, in here, if you execute these commands in the console of the DataCamp interface, you will be redirected to www.rdocumentation.org. A quick hack to see the arguments of the sample function is the args function. Try it out in the console. args sample. In the next exercises, you'll be learning how to use the main function with increasing complexity. The first thing you'll have to do is get acquainted with the main function. Instructions. Consult the documentation on the main function, !mean or help mean. Inspect the arguments of the main function using the arguments function. All right. So what do we do over here? Consult the documentation. Okay, easy. So we're just going to go !mean. And over here, we can go args mean. All right, let's try that. Great, that wasn't too hard, was it? Take a look at the documentation and head over to the next exercise. Use a function. The documentation on the mean function gives us quite some information. The mean function computes the arithmetic mean. The most general method takes multiple arguments, x and. The x argument should be a vector containing numeric, logical, or time-related information. Remember that R can match arguments both by position and by name. Can you still remember the difference? You'll find out in this exercise. Once more, you'll be working with the view counts on your social network profiles for the past 7 days. These are stored in the LinkedIn and Facebook vectors and have already been defined in the editor on the right. Instructions: calculate the average number of views for both LinkedIn and Facebook and assign the result to avg_li and avg_fb, respectively. Experiment with different types of argument matching. Print out both average for LinkedIn and average for Facebook. Okay, so first thing we're going to do is go over to the right and calculate average number of views. So avg_li mean LinkedIn and avg_fb mean Facebook. Next, inspect the average. So we're just going to go AV. So we're going to print these avg_li, avg_fb. Submit answer. Nice. I'm sure you've already called more advanced R functions in your history as a programmer. Now you also know what actually happens under the hood. Press enter to continue. Use a function. Check the documentation on the main function again. The usage section of the documentation includes two versions of the mean function. The first usage is this. This is the most general usage of the mean function. The default S3 method, however, is right here. The three dots is called the ellipsis. It is a way for R to pass arguments along without the function having to name them explicitly. The ellipses will be treated in more detail in future courses. For the remainder of this exercise, just work with the second usage of the mean function. Notice that both trim and na.rm have default values. This makes them optional arguments. Instructions. Calculate the mean of the element-wise sum of LinkedIn and Facebook and store the result in a variable, average sum. Calculate the mean once more, but this time set the trim argument equal to 0.2 and assign the result to average sum trimmed. Print out both average sum and average sum trimmed. Can you spot the difference? Okay, so we'll come over to the right-hand side, and the first thing we have to do is calculate the mean of the sum. So in order to do that, we'll go avg underscore sum and mean. LinkedIn plus Facebook. Next, we want to calculate the trimmed mean of the sum. So to do that, avg sum trimmed, and we want it to mean LinkedIn plus Facebook, comma, trim equals to 0.2. And that was given to us over here. And then next, we just have to inspect both new variables. So let's check it out. avg underscore sum, whoops, and avg underscore sum underscore trimmed. Submit answer. Nice. When the trim argument is not 0, it chops off a fraction equal to trim of the vector you pass as argument x. Press enter to continue. Use a function. In the video, Philip guided you through the example of specifying arguments of the SD function. The SD function has an optional argument, na.rm, that specified whether or not to remove missing values from the input vector before calculating the standard deviation. If you've had a good look at the documentation, you'll know by now that the mean function also has this argument, na.rm, and it does the exact same thing. By default, it is set to false, as the usage of the default S3 method shows. Here, let's see what happens if your vectors, LinkedIn and Facebook, contain missing values, NA. Instructions. Calculate the average number of LinkedIn profile views without specifying any optional arguments. Simply print the result to the console. Next, calculate the average number of LinkedIn profile views, but this time tell R to strip missing values from the input vector. All right, so we'll come on over to the right. And basic average of LinkedIn. So what we're going to do is go print mean LinkedIn and make sure our syntax is good. Cool. Next, advanced average of LinkedIn. So we're going to go print mean LinkedIn, comma, trim equal to 0 and a.rm equal to true. And let's submit that. Oh, you know what? I just mentioned that we need to check our syntax. So again, down here, we see that there's two open parentheses. So we also need two closed parentheses. I made a silly mistake. I only used one. So by adding the second one, that should fix our problem. So let's go ahead and check that again. Submit answer. Cool. If you ever get an error, it's probably just a silly syntax error. So just make sure that your syntax looks good. And now we will continue. So awesome. Up to the next exercise. Functions inside functions. You already know that our functions return objects that you can then use somewhere else. This makes it easy to use functions inside functions, as you've seen before. Notice that both the print and paste functions use the ellipsis as an argument. Can you figure out how they're used? Instructions. Use ABS on LinkedIn minus Facebook to get the absolute differences between the daily LinkedIn and Facebook profile views. Place the call to ABS inside mean to calculate the mean absolute deviation. In the mean function call, make sure to specify na.rm to treat missing values correctly. Okay, so let's go over to the right-hand side, and we have to calculate the mean absolute deviation. So mean, ABS for absolute, then we're gonna go LinkedIn minus Facebook, and then we'll go comma, trim equal to 0, na.rm equal to true. And let's try that. Submit answer. Excellent. Proceed to the next exercise. All right, so required or optional. By now, you will probably have a good understanding of the difference between required and optional arguments. Let's refresh this difference by having one last look at the mean function. X is required. If you do not specify it, R will throw an error. Trim and na.rm are optional arguments. They have a default value which is used if the arguments are not explicitly specified. Which of the following statements about the read.table function are true? And here we have 4 options. 1, header, sep, and quote are all optional arguments. 2, row.names and file encoding don't have default values. 3, read.table, this right here, will throw an error. 4, read.table, this will throw an error. Possible answers. So which of the following statements about read.table function are true? 1, 3. Great. Using functions that are already available in R is pretty straightforward. But how about writing your own functions to supercharge your R programs? The next video will tell you how. So feel free to watch this video on your own. But to stay focused on the exercises, let's go ahead and move on to the next exercise. Write your own function. Wow, things are getting serious. You're about to write your own function. Before you have a go at it, have a look at the following function template right here. Notice that this recipe uses the assignment operator, this, just as if you were assigning a vector to a variable, for example. This is not a coincidence. Creating a function in R basically is the assignment of a function object to a variable. In the recipe above, you're creating a new R variable, my_fun, that becomes available in the workspace as soon as you execute the definition. From then on, you can use the my_fun as a function. Instructions. Create a function, POW underscore TWO. It takes one argument and returns that number squared, that number times itself. Call this newly defined function with 12 as input. Next, create a function, sum underscore ABS, that takes two arguments and returns the sum of the absolute values of both arguments. Finally, call the function sum underscore ABS with arguments -2 and 3 afterwards. Okay, so looking on the right-hand side, first we want to create a function, POW underscore TWO. So POW underscore TWO function X. Y. Oops. Function TWO, assignment, function X, and then Y. X. So let's see, Y, X, okay, and then return Y, and okay. Next, use the function. Okay, so POW underscore 2. Then next, create a function, sum underscore ABS. So sum underscore ABS function WX let's see, return Y, and then use the function. So sum that -2, 3. All right, let's see if that looks good. Submit answer. Great. Step it up a notch in the next exercise. Don't mind if I do. Write your own function. There are situations in which your function does not require an input. Let's say you want to write a function that gives us the random outcome of throwing a fair die. Up to you to code a function that doesn't take any arguments. Instructions. Define a function. Hello. It prints out hi there and returns true. It has no arguments. Call the function hello without specifying arguments, of course. Okay, so define the function hello. We'll go hello function, and then print hi there, and then return true. And boom. And then call the function. Okay, so hello. Submit answer. Truly impressive. Head over to the next exercise. Cool. Write your own function. Do you still remember the difference between an argument with and without default values? Have another look at the standard deviation function by typing $SD in the console. The usage section shows the following information. This tells us that x has to be defined for the SD function to be called correctly. However, na.rm already has a default value. Not specifying this argument won't cause an error. You can define default argument values in your own R functions as well. You can use the following recipe to do so. The editor on the right already includes an extended version of the POW underscore TWO function from before. Can you finish it? Instructions. Add an optional argument named print underscore info that is true by default. Next, wrap an if construct around the print function. This function should only be executed if print underscore info is true. Feel free to experiment with the POW underscore TWO function you've just coded. All right, so let's go over to the right side. Finish the POW TWO function. Okay, so let's look at this. POW underscore TWO function X. So this is what we got to do. Print underscore info equals true. And if print underscore info true, then print paste x to the power equals y. Return y, boom, and then POW underscore TWO. Let's try this. Wonderful. Have you tried calling this POW underscore TWO function? And you can try these. So excellent. Let's continue to the next exercise. And the next exercise is function scoping. An issue that Philip did not discuss in the video is function scoping. It implies that variables that are defined inside a function are not accessible outside that function. Try running the following code and see if you understand the results. Y was defined inside the POW underscore TWO function, and therefore it is not accessible outside of that function. This is also true for the function's arguments, of course, x in this case. Which statement is correct about the following chunk of code? The function to underscore dice is already available in the workspace. Possible answers. Executing to underscore dice causes an error. Executing this makes the contents of dice1 and dice2 available outside of the function. Whatever the way of calling the two dice function are won't have access to dice1 and dice2 outside of that function. Well, obviously this one. Great. If you're familiar with other programming languages, you might wonder whether R passes arguments by value or by reference. We'll find out in the next exercise. R passes arguments by value. The title gives it away already. R passes arguments by value. What does this mean? Simply put, it means that an R function cannot change the variable that you input to that function. Let's look at a simple example. Try it in the console. Inside the triple function, the argument x gets overwritten with its value times 3. Afterwards, this new x is returned. If you call this function with a variable a set equal to 5, you obtain 15. But did the value of a change? If r were to pass a to triple by reference, the override of the x inside the function would ripple through to the variable a outside the function. However, r passes by value. So the R objects you pass to a function can never change unless you do an explicit assignment. A remains equal to 5 even after calling triple A. Can you tell which one of the following statements is false about the following piece of code? So go ahead and look at this piece of code and let's try to figure this out. Instructions, possible answers. A and B equal to 7 and 6 respectively after executing this block. After the first call of increment, where a is defined, a equals 7 and count equals 5. In the end, count will equal 10. In the last expression, the value of count was actually changed because of the explicit assignment. In the end, count will equal to 10. Well done. Given that R passes arguments by value and not by reference, the value of count is not changed after the first two calls of increment. Only in the final expression where count is reassigned explicitly does the value of count change. Let's continue to the next exercise. Are you functional? Now that you've acquired some skills in defining functions with different types of arguments and return values, you should try to create more advanced functions. As you've noticed in the previous exercises, it's perfectly possible to add control flow constructs, loops, and even other functions to your function body. Remember our social media example? The vectors LinkedIn and Facebook are already defined in the workspace, so you can get your hands dirty straight away. As a first step, you will be writing a function that can interpret a single value of this vector. In the next exercise, you will write another function that can handle an entire vector at once. Here are our instructions. Finish the function definition for interpret that interprets the number of profile views on a single day. The function takes one argument, num underscore views. If num underscore views is greater than 15, the function prints out you're popular to the console and returns num underscore views. Else, the function prints out try to be more visible and returns 0. Finally, call the interpret function twice on the first value of the LinkedIn vector and on the second element of the Facebook vector. All right, so let's look over on the right and see what we have to do. So we'll start around here. Interpret function num views, okay. If num underscore views is greater than 15, then we're gonna go print your popular. Whoops, yeah, that's better. And then return num underscore views. And then, okay, so far so good. Here, let's go print and try to be more visible and return 0. Anything else we have to do? Yeah. Call the interpret function twice. So we'll go interpret linked in 1 and interpret Facebook 2. Let's try that. Submit answer. Funkadelic. The annoying thing here is that interpret only takes one argument. Proceed to the next exercise to implement something more useful. Are you functional? A possible implementation of the interpret function is already available in the editor. In this exercise, you'll be writing another function that will use the interpret function to interpret all the data from your daily profile views inside a vector. Furthermore, your function will return the sum of views on popular days if asked for. A for loop is ideal for iterating over all the vector elements. The ability to return the sum of views on popular days is something you can code through a function argument with a default value. Instructions. Finish the template for the interpret all function. Make return underscore sum an optional argument that is true by default. Inside the for loop, iterate over all views. On every iteration, add the result of interpret v to count. Remember that interpret v returns v for popular days and 0 otherwise. At the same time, interpret v will also do some printouts. Finish the if construct. If return underscore sum is true, return count, else return null. Call this newly defined function on both LinkedIn and Facebook. So let's go over to the right-hand side and see what we have to do. Let's see, interpret function, okay. 7 if num views greater than 15, print your popular, return num views, else, print try to be more visible, return 0, okay. All right, so here's the new stuff that we have to do. Define the interpret all function. So use return sum true for v in views count plus interpret, boom. If return underscore sum boom, return count, else return null. We're almost there. Call the interpret all function on both LinkedIn and Facebook. Okay, so we'll go interpret all first on LinkedIn. And then one more time, interpret all, this time on Facebook. And submit answer. Perfect. Have a look at the results. It appears that the sum of views on popular days are the same for Facebook and LinkedIn. What a coincidence. Your different social profiles must be fairly balanced. Head over to the next video. All right. So we'll go ahead and advance through this video so we can continue with our exercises. So here we have load in our package. There are basically two extremely important functions when it comes down to our packages. We have install.packages, which, as you can expect, installs a given package. Library, which loads packages, attaches them to the search list on your R workspace. To install packages, you need administrator privileges. This means that install.packages will thus not work in the DataCamp interface. However, almost all CRAN packages are installed on our servers. You can load them with the library function. In this exercise, you'll be learning how to load the ggplot2 package, a powerful package for data visualization. You'll use it to create a plot of two variables of the mtcars data frame. The data has already been prepared for you in the workspace. Before starting, execute the following commands in the console. Search function to look at the currently attached packages, and qplot, this right here, to build a plot of two variables of the mtcars data frame. An error should occur because you haven't loaded the ggplot2 package yet. All right, so instructions. To fix the error you saw in the console, load the ggplot2 package. Make sure you are loading and not installing the package. Now retry calling the qplot function with the same arguments. Finally, check out the currently attached packages again. All right, so let's go ahead and follow the instructions. First, we'll load the ggplot2 package. So we'll go library, ggplot2. Retry the qplot function. So we'll go qplot mtcars $WT. mtcars $HP. And then check out the currently attached packages again. So we'll go search, submit answer. Awesome. Notice how search and library are closely interconnected functions. Head over to the next exercise. Press enter to continue. Different ways to load a package. The library function and require function are not very picky when it comes down to argument types. Both library RJSON and library RJSON in quotes work perfectly fine for loading a package. Have a look at some more code chunks that attempt to load one or more packages. All right, so we have chunk 1, chunk 2, chunk 3, and chunk 4. And I'll give you a moment to look at those chunks. Next, what we want to do is select the option that lists all of the chunks that do not generate an error. The console on the right is yours to experiment with. So by looking at the chunks, chunk 1, okay, looks good. Chunk 2 also looks good. And let's try 1 and 2. Great. Indeed, only chunk 1 and chunk 2 are correct. Can you figure out why the last two aren't valid? This exercise concludes the chapter on functions. Well done. Awesome. So that completes our tutorial on Intermediate R, Chapter 3 on functions. I will go ahead and film a distinct video for the next lesson, Intermediate R, Chapter 4. And Chapter 4 will focus on the apply family. Thank you.